Good morning, ma'am. Good morning, classmates. So I'm here to present to all of you the contribution of electricity and magnetism. So first, ano muna yung mga past lesson natin? Ano muna yung mga napag-aralan natin bago yung ito? So, ano yung mga na-discuss nila Renzi at Domingo na ano naman yung na-discuss nila Paes and ni Gracie? Tutungo na tayo sa susunod. So, sayang lang dahil hindi tayo makakapag-icebreaker dahil video presentation lamang ito at walang prize, kawawa naman. So, okay lang yun. Tutungo na tayo dito sa ating agenda. Dito makikita natin kung ano yung mga tatalakayin natin. Electricity. So, ano nga ba ang electricity? Ang electricity exists in the smallest particle in the nature called the atom. So, the atom is the basic building blocks of matter. An atom is so small that humans' eyes cannot see it. So, ano naman ang magnetism? It's one aspect of the combined electromagnetic forces. It refers to physical phenomena arising from the forces caused by magnets. So, ayun, next na tayo. Ano ang ating objective? Ang objective natin is to explain the contribution of Franklin, Coulomb, Ørsted, Ampere, Biot-Savart, Faraday, and Maxwell to our understanding of electricity and magnetism. So sila yung mga scientists na nagbigay sa atin ng kaalaman about sa electricity and magnetism. Here are some scientists who made significant contribution to the fields of electricity and magnetism. Una na dyan si Benjamin Franklin was the first American who contributed in the field of electricity. So, according to Franklin, electricity is a fluid. So, he was the first person who used the term positive and negative charges. He used the word positive meaning more fluid and negative meaning less fluid. Today, we know the moving fluid as the electrons. So, Franklin was also the first who stated the concept of conservation of electricity. Next is kite experiment. Franklin's famous kite experiment during a thunderstorm proved that lightning was a form of electrical discharge from storm clouds. So, he used the kite and the metal key to attach to it. So, to attract the lightning and indeed it too. At dahil dun sa kite experiment niya, naka-invento siya ng lightning rod. So, sa point metal conductor placed on top of building to safely direct lightning strike to the ground. So, yung lightning rod, nakalagay siya sa pinakatuktok ng building or houses. At nakakonekta siya sa lupa. The lightning rods serve as pathway for lightning to the ground instead of damaging a house. Lightning rods are essential safety device that protect structures from lightning damage. So yun. So dahil din sa lightning rod, hindi ka na So next is Charles Augustin de Coulomb, a French physicist known for formulating an equation describing the force between two electric charges. So we call this Coulomb's law. This law states that the force between two electric charges is directly proportional to the product of the charges, inversely proportional to the square of the distance between them. So here's the formula of Coulomb's law. So F is equal to K Q1 times Q2 all over R2. So the F is electric force, the K is Coulomb's constant, the Q1 and Q2 is charges, the R is the distance of separation. Meron akong video, sayang hindi niya mailagay dito, kaya patuloy na tayo. So, torsion balance. Coulombs also invented several machines, including the torsion balance. So, torsion balance was initially used to measure the density of Earth, but proved more effective in measuring weak forces. So, here's the picture, as you can see, what you understand about that. So, torsion balance is an instrument used to measure the minute forces as electrostatic or magnetic attraction and repulsion. By the torsion of a wire or filament, the angle of torsion being proportional to the amount. In the short explanation, torsion balance is device used to measure the gravitational acceleration at the Earth's surface. So next is Hans Christian Ørsted. He was a Danish physicist and chemist who accidentally discovered the connection between electricity and magnetism. So, the experiment. While lecturing about electric circuit, Ørsted, he noticed a compass needle deflecting when he turned the circuit on and off. So, here's the video. So, as you can see in the video, Hans Christian Ørsted showed that the moving charge creates a magnetic field. Magalaw siya. So, Ørsted showed that electric current produces a circular magnetic effects around it. So sunod, si André-Marie Ampère, a French physicist who made significant contribution to the field of electromagnetism that described the magnetic force between two current-carrying wires. Ampere's groundbreaking work stemmed from his observation of the relationship between electricity and magnetism. He conducted experiments with parallel current-carrying wires, discovering that they attract when the current flows in the same direction and repel when the current flows in opposite direction. In recognition of his contribution, the unit of the electric current, the ampere, was named after him. Ampere also made several inventions that advanced the field of electromagnetism. So, one notable invention was the galvanometer, a device that detects the presence of an electric current. So, next, Jean-Baptiste Biot and Félix Savart. So, there are French scientists who formulated an equation named after them. So, it calls Biot-Savart. So, tells about fundamental quantitative relationship that exists between electric current and magnetic field. So here's the Biot-Savart law. It calculates the magnetic field at the point due to a current element. It states that the magnetic field is
proportional to the current and length of the element, inversely proportional to the square of the distance from element. Each infinitesimal current element makes a contribution to the magnetic field at point P, which is perpendicular to the current element and perpendicular to the radius vector from the current element to the field point P. So, the Biot-Savart law describes how electric current generate magnetic fields, akin to how Coulomb's law explain the relationship between electric fields and point charge. In the short explanation, ang Biot-Savart law explain how magnetic fields interact with wires. So, the relationship between the magnetic field contribution and its source current element is called the Biot-Savart law. So, next na si Michael Faraday, one of the world's greatest experimental physicists. Is known as the father of the electric motor, electric generator, electric transformer, and electrolysis. So he studied the work of Ørsted and Ampere, which inspired his understanding of the relationship between magnetism and electricity. So Michael Faraday discovered the electromagnetic induction and the concept of electromagnetic fields. So, Faraday called experiment showed that changing magnetic field induces electric current. So, here's the video you need to watch para mas maintindihan nyo. So, naintindihan niyo na ba yung Paradise experiment, kung paano siya gumagana, ano na itutulong niya sa atin? So, tutungo na tayo kay James Clerk Maxwell. Scottish physicist is known for his four equations that describe the behavior of electric and magnetic fields. Maxwell used Paradise and Ampere's finding and combined them to create four equations that mathematically describe the behavior of electricity and magnetism, being considered as inseparable. Maxwell unified electricity and magnetism with his famous equation. So, yun yung per equation. So, Maxwell equation describe how electric and magnetic fields interact. So, here's the summary for all that I presented. Sa lahat po ng na-report ko, pakibasa nyo na lang po para mas maintindihan nyo kung ano ba talaga yung mga naitulong nila sa atin. Yun lamang po. Thank you.